Hi you guys, how are you today? Today we're going to be going over lesson 921. The first question we're asked is, what kind of triangle can I make? So if we're given three different lengths, they would create the three sides of the triangle. So the question is, what lengths will make a triangle, and then what kind of triangle do they make? So I've drawn here some line segments of different lengths. We've got a 22 centimeter, 10 centimeter, 7 centimeter, and 15 centimeter line. But then I cut straws that are those lengths so that we could build triangles using the straw pieces as our sides and see which ones will create a triangle. So I'm going to start with the largest length, 22, and then let's use the next one down, side length of 10, and I'm going to match them up end to end so you could see it creates this vertice of the triangle here. And then I'm going to add the 7 centimeter piece in and match it up there, and you can see that these three lengths just aren't going to match up end to end and create a triangle. So I'm going to list those lengths over here in my column of doesn't make a triangle. So 7, 10, and 22 centimeter side lengths did not create a triangle. Let me put these back, and we'll move on to another combination. For this one, let's use the 10 centimeter side length, the 15 centimeter side length, and the 22. Okay, you can see it's really not going to work the way I have it there, but let's change things around a little bit. That's the beauty of using these straws. Much easier than drawing and erasing lines. If I move it like that and put the 22 at the base, you could see that this one will create a triangle. So let's put that over here on this left-hand column that does make a triangle with 10, 15, and 22. Okay. For the next combination, we are going to keep the 22 down here and get the 15 and 7 centimeter lengths. Okay, you can see it doesn't quite work like that, but I can move things around a little bit. Sorry about the glare over there coming in the window, you guys. It's about 7:30 in the morning and the sun's just coming up, and the glare's kind of making things difficult for us to see here. Still not quite there, so I'm going to push these down a little bit more, keep flattening out this triangle. Still not quite touching. Still, oh, went all the way down and never formed a triangle. So these three lengths did not work. That was 7 and 15 and 22. Let's try one more. Let's see. I'm going to put the 22 away now and replace it with a 10. So we've got the 10, the 7, and the 15. So I'm just going to keep the 15 down there at the base. Here's the 10. Here's the 7. And it's not quite working the way I have it there. Let's see if I can push these two a little closer together. It'll work. And voila, there we go. Those three do create a triangle. So let's put them over here. That was 7 and 10 and 15. Okay, now we're going to look at this data we collected here and see if we can figure out a pattern with the numbers that do make triangles and that do not. So I'm going to ask you to focus on the first two side lengths. So in this particular case, we had 10 and 15. If you find the sum of 10 and 15, it's 25. So we have 25, and then our third side length is 22. Let's look at these first two side lengths. We have 7 and 10, and their sum is 17. And then we have the third side length that has a length of 15. Now let's look over here on the ones that didn't make a triangle. If we look at the first two side lengths, 7 and 10 have a sum of 17, and that third side length is 22. And these ones, we have 7 and 15, whose sum is 22, and the third side length is 22. Take a moment and analyze those. 25, 22, 17, 15. Let's come over here. 17 and 22, and 22 and 22. What I notice is that the sum of these two smaller sides is larger than the third side. Same thing here. The sum of the two smaller sides, 17, is larger than 15. Over here in the right-hand column, the ones that didn't form a triangle, 17 is less than 22, and here 22 is equal to 22. So the three side lengths that will form triangles have in common that the two shorter sides add together to create a sum greater than the third side length. So let's put that into words. This answers our first question, what lengths will create a triangle? Three side lengths will form a triangle when the sum of the two smaller lengths is greater than the third length. Okay, the title of the lesson is What Kind of Triangle Can I Make? Well, now we know what three sides will make a triangle, but we're going to focus on what kind of triangle those lengths will make. The types of triangles, again, are acute triangles, obtuse triangles, and right triangles if we're classifying them by their angles. So here we have a triangle that is acute. It's got a side length of 10, 7, and 15 centimeters. Well, thank goodness for the pause button, because I was able to pause the video when I realized I had made an error in what I said before. These three side lengths, 10, 7, and 15, actually create an obtuse triangle because this angle right here is greater than 90 degrees. So we're going to look at this statement here that says the sum of the areas of two smaller sides is less than the area of the longest side, then the sides will form an obtuse triangle. So that's what we have here. But what is this saying about the sum of the areas of the two smaller sides? So if I drew a square on the edge of this triangle that was a 7 by 7 square, that means we would have a base and a height, or a length and a width of 7, and the area of that would be 7 times 7, or 7 squared. If I did the same thing over here, I don't quite have enough room to draw a square with side lengths of 10, but you get the idea. If I sketched a square here, it would be 10 by 10, and 10 times 10, or 10 squared, would look like that. So here I have the sum of the areas of the two smaller sides, 10 squared plus 7 squared. Then we need to do the same thing. If I drew a square here that was a 15 by 15 square, that area would be 15 squared. And this is saying, let's figure out what this is. 7 squared is 49, plus 10 squared is 100. If we add these two together and find the sum of the area of the two smaller sides, we get 149. If we square the longest side, 15 squared is 225. 149 is less than 225. So we can see if the sum of the areas of the two smaller sides is less than the area of the longest side, it will form an obtuse triangle. Okay, let's move on to a new triangle. Here we have a triangle whose side lengths are 6 units, 5 units, and 4 units. And this statement says that the sum of the areas of the two shorter sides is greater than the area of the longest side. Then the lengths will form an acute triangle. So if we drew a square here that was a 4 by 4, its area would be 4 times 4, or 4 squared. If we drew a square here that had side lengths of 5 and 5, its area would be 5 squared. And we're going to add those two together because we're looking for the sum of the areas of the two shorter sides. And we're going to compare that to the area of the square of the longest side. So if we drew a square that was 6 by 6, its area would be 6 squared. So let's compare those. 4 squared plus 5 squared, and compare that to 6 squared. Okay, the sum of 16 and 25 is 41. We're going to compare that to 36. So 41 is greater than 36. So if the sum of the areas of the two shorter sides is greater than the area of the longest side, it will form an acute triangle. All angles are less than 90 degrees in an acute triangle. Okay, for our last of these types of examples, we have a triangle that has lengths of 3 units, 4 units, and 5 units. And this statement says, if the sum of the areas of the two shorter sides is equal to the area of the longest side, then the lengths will form a right triangle. So let's take a look at that. If we had a square that was 3 by 3, 3 by 3, its area would be 3 squared. And if we had a square that was 4 by 4, 4 by 4, its area we would get by multiplying 4 times 4, or 4 squared. And we're looking at the sum of the area of the two shortest sides. We're going to compare that to the area if we were to square the longest side. So if we had a 5 by 5 square, there we go, 5 by 5 square, we would get its area by multiplying 5 by 5, or 5 squared. So let's compare those. 3 squared is 9, 4 squared is 16. If we add those together, we get a sum of 25. And if we square the longest side, 5 times 5 is 25, and you can see in this particular case, those areas are equal. And this statement says if the sum of the two shorter sides, the areas of the two shorter sides is equal to the area of the longest side, it will form a right triangle. If you go back and analyze the triangle that we started with right here, you can see that we do indeed have a right angle in this bottom left corner, so that is a right triangle. Okay, we're going to do a couple of example problems now, given all of that information that we just learned about whether or not three lengths will form a triangle, and if they do, what type of triangle it is. So the question is, will the given lengths form a triangle? If so, what type of triangle? For example 1, we have lengths of 5 centimeters, 6 centimeters, and 7 centimeters. So the first question is, will they form a triangle? So in order to form a triangle, we learned that the sum of the two shorter sides must be greater than the third side. So let's add them up. 5 plus 6, those are our two shortest sides, and 7 is our third side. And we have a sum here of 11. And in order for it to form a triangle, the two shortest sides must be greater than the third. 11 is indeed greater than 7, so yes, they will form a triangle. Okay, so the direction said if they will form a triangle, what type of triangle will they form? So to figure out what type of triangle we're working with, we need to find the area of the sides, the two shortest sides and the longest side, and compare them. So to find the area, we would square that. So 5 squared plus the area of the next shortest side, and we are going to compare that to the square of the longest side. So 5 squared is 25, plus 6 squared is 36, and 7 squared is 49. Let's find the sum here so then we can compare it to this. 25 plus 36 is 61, and we're going to compare that to 49. 61 is greater than 49. So we learned that when the sum of the areas is greater than the square of the longest one, it will form an acute triangle. So that is our answer. They will form an acute triangle. For example 2, we are given side length 6 centimeters, 7 centimeters, and 20 centimeters. And the first question we're asked is, will these lengths form a triangle? So we need to add the two shortest sides together, 6 plus 7, and compare them to the longest side. In order for them to form a triangle, the sum of the two shorter sides must be greater than the length of the third side. 6 plus 7 is 13, and 13 is actually less than 20, so the answer is no, the lengths will not form a triangle. Okay, for our third example, we have lengths of 10 centimeters, 24 centimeters, and 26 centimeters. The first question we have to answer is, will these three lengths form a triangle? So let's find the sum of the two shorter sides and compare that to the length of the third side. 10 plus 24 is 34, which is indeed greater than 26. So our answer is yes, these three lengths will form a triangle. The next thing we need to determine is what type of triangle will they form. So I'm just going to draw a little line here for separation, and we'll work the second part over here on the right hand side. To figure out what type of triangle, we're going to look at the areas or the squares of the sides and compare them. So we need to add the squares of the two shorter sides together. So 10 squared plus 24 squared, and we need to compare that to 26 squared. Okay. 10 squared, 10 times 10 is 100. 24 squared, or 24 times 24, is 576. And 26 squared, or 26 times 26, work it out on the calculator here, is 676. Now if we find the sum of the two shorter sides, we get 676. Compare that, to the square of the longest side, which was also 676. We can see that they're equal. So these three lengths, or the lengths, will form what type of triangle if they're equal? It will be a right triangle. Okay, that's the end of our lesson for today, and today's assignment is just to watch this video. So you are done for today. Tomorrow you will be working on the review preview problems listed on the April calendar for lesson 921. Have a great rest of your day, you guys.